Hello everyone, welcome to the MathStem Science Summer Camp, hosted by Middleton Robotics. I am your resident mad scientist, Leo, and today we're going to be talking about the fascinating substance that is water. Now you may not think water is that interesting, but it really has some interesting properties. And one of the things that I love about water is how some things float on it. And not everything floats on it. If I have this feather, which is really light, it'll float on the water, and I have this hammer, which is really heavy, it's going to sink. But it's not that simple. If something's light, it floats. If something sinks, it's heavy. What it really has to do with is density. Now, density is a fancy term for saying how heavy something is relative to its size. There, we got you back there. For how heavy it is relative to its size. So this paper clip, well, it may be light. It's still heavier than the water that it displaces. And, it's really small as well. And, something that's really, really heavy, like, say, a log from a tree, it's also really large. So if I put it in obviously not this cup, but like in a lake, it'll float, actually. And, asking these sort of questions, will something float, will it sink, it leads you to take some sort of experiment. And we're actually going to send you to an experiment right now, and we'll see how many you can guess correctly. So in this experiment, you're gonna take a look at 3 different liquids and see what you think will float and sink through each of them.
Alright, welcome to our very first experiment. As you can see, our 3 liquids are vegetable oil, which is at the top as it has the lowest density, some orange dyed water, and corn syrup, which is all the way at the bottom as it is the most dense. We're going to drop some items into this cup and see where they end up floating based off of their density. Our first item here is a 50-cent coin, which is in fact made of metal. Metal normally is pretty dense, so where do you think it'll end up? If you guess it'll go all the way to the bottom through all the layers, you got it right. Nice job. Metal is more dense than even corn syrup, so it sinks all the way to the bottom. Our second item is a plastic water bottle cap. Will it sink through like the coin? Make your prediction now. The plastic cap is less dense than the water, so it floats on top of the water layer. It still is more dense than the vegetable oil though, so it sinks through the top layer. Our third item is a carrot. Now, carrots are pretty heavy, but not as heavy as metal. I wonder where it'll end up. What do you think? Through the water, but on top of the syrup. Was your prediction correct? Do you think that did you know that the carrot was less dense than the corn syrup? Finally, we have a cork. It's lightweight and full of air pockets. Based on what you know, what do you think will happen? Oh, the cork has such little density, it floats on top of all the layers, even the vegetable oil. I know, I was surprised about that outcome. How many guesses out of 4 did you get right? If you didn't get them all, I know I didn't. That's okay. Science is all about trying things out and learning, and in the end, we all learned about densities that will make things float or make them sink.
Hi, welcome back. How many did you get right? Did you get them all? Now, density isn't the only thing that determines whether something will sink and float. There's this really special property about water. Let me show you. Oh hey, welcome back. Didn't see you here. And here we have a close-up of our glass of water. Now you might remember from earlier, if we just have any old paper clip and just put it in, because it's made of metal and its density is higher than water, it will sink. Now, I want to show you an experiment that I really think you'll love. So I have this paper towel here, just regular paper towel, and another paper clip. And if I put this just so gently on top of the water, we'll notice the paper towel starts to fill up with water. Now, that's increasing the density, and as the density increases, the paper towel will begin to sink a little bit, right? And we can see it's going down just a little bit. I'm going to expedite the process a little bit and poke it around with this toothpick. Now, you see something special going on. So the paper clip is still floating, despite that the paper towel is up here. And the reason why the paper clip is floating is because of surface tension. Now, surface tension is a cool property of water. And surface tension, it's so unique. It can hold up something that's less dense than water, so it's stronger than the force that the water puts up on it. Now, there's some other fun things you can do with surface tension. This is just regular old dish soap. I'm just putting in this little container here for your view. Now, normally when I take this cotton swab, I poke it around in the water does nothing, you know. You see the paperclip, it's just doing fine. But instead, if I put some dish soap on the cotton swab and then I hold it in the water, it falls right out. Isn't that cool? The surface tension was broken by the dish soap.
So in review, we learned about whether things will float or sink in water based off of their densities and surface tension. Density is how heavy something is for its size. Something less dense than water, like a tree log, will float in it, while something more dense, like a paperclip, will sink. Surface tension forms at the surface of water. This layer can hold up items that are more dense than water if placed carefully so that the surface tension is not broken. That surface tension can be broken across the water by using soap. You know, surface tension is responsible for making belly flops hurt. Well, thanks for watching this video on the wonderful world of water. Did you learn something new about density and surface tension? Make sure to catch our other camp videos for more fun experiments in science.